In this video, I'll be solving January 2019, Paper 2, Question 3. Part B. The diagram below shows a right angle triangle with sides A units, B units, and C units. Part 1A. Using the diagram, express C in terms of A and B for 1 mark. In our diagram, C is the hypotenuse because it is the longest side of the triangle and it is opposite the right angle. So I will label here that C is equal to the hypotenuse. Now, Pythagoras Theorem states that the hypotenuse square is equal to the sum of the squares of the other two sides. So what this means is that C squared is equal to A squared plus B squared. So I will write this here by Pythagoras Theorem. C squared is equal to A squared plus B squared. Now, in order to express C in terms of A and B, I need to make C the subject of the formula. So I will take the square root on both sides of the equation. So this becomes here C is equal to the square root of A squared plus B squared. Part B. Write in terms of A, B, and C an expression for sine theta plus cos theta for 2 marks. Now, in our diagram here, B is the side next to theta, so B is the adjacent side, and A is the side that is opposite angle theta, so A here is the opposite side. Now, sine theta is equal to opposite over hypotenuse. So on our diagram here, the opposite is A and the hypotenuse is C. So sine theta is A over C. And cos theta is equal to adjacent over hypotenuse. In our diagram here, the adjacent is B and the hypotenuse is C. So cos theta is B over C. So I'll write this in here. B over C. Now, they want us to write an expression for sine theta plus cos theta. So I'll write here that sine theta plus cos theta is equal to, we know that sine theta is A over C. So I'll write here A over C, and cos theta is B over C. So I'll write here B over C. Now, notice that these fractions here have the same denominators, so we can add them. So this is A plus B all over C. Part 2. Using the results from Part 1A and B on page 12, show that sine theta squared plus cos theta squared is equal to 1 for 2 marks. So I'll start off here by writing sine theta squared plus cos theta squared. Now from part 1b, we found here that sine theta is equal to A over C and cos theta is equal to B over C. So I will substitute these values here. Sine theta is A over C and this will be squared, and cos theta is B over C and this will also be squared. Now, by the laws of indices, these can be expressed as A squared over C squared plus B squared over C squared. Notice here that the denominators are the same, so this can simplify to be A squared plus B squared all over C squared, and I'll call this equation 1. Now, from part 1a, we learned that by Pythagoras Theorem, C squared is equal to A squared plus B squared. So, I'll write here, by Pythagoras Theorem, C squared is equal to a squared plus b squared, and I'll call this equation 2. Now I will substitute here equation 2 into equation 1. What this means is wherever I see a squared plus b squared, I will replace it with c squared. So this is equal to c squared divided by c squared, which is equal to 1. So therefore, sine theta squared plus cos theta squared is equal to 1 QED.